In this video, we'll be doing some actual applied problems and using the algebra of solving systems to figure out the answers to some hypothetical questions. And in your homework, I'm going to give you a couple fresh problems that are a little bit different because one important thing when it comes to real problems is being able to actually write the system of equations. Like, knowing how to actually do the algebra as we've been doing is one thing, but being able to actually understand the problem and understand what the equation should look like is another. That's kind of my main focus for these videos is how do I write the equation? And then once I do, it's just a matter of solving by algebra. So let's look at an example of equalizing cost, which in these problems, the goal is to make sure the costs at different places are the same, which is kind of where the system comes from. But let's just go ahead and read it. And step number one is to write a system of equations. Because technically, you could solve these sorts of problems. And we had some of these back in chapter one that you guys were able to solve. But if I can't write the equation, obviously I can't use my algebra. But it says wood furniture is made by Megacorp at facilities in San Diego and Los Angeles. The San Diego facility has a fixed cost of $8,000 per month, and it costs them $12 to produce each piece of furniture. Whereas the LA facility has a fixed cost of less, $3,400, but they cost them more, $14 to produce each piece of furniture. It says next month they must produce 2,000 pieces of furniture. And we want to know how should we divide up the furniture to each of their facilities if we want to equalize the cost. So we could just say, okay, facility 1, make 1,000 pieces of furniture, facility 2, make 1,000, but that wouldn't necessarily guarantee that they have the same cost. But if we want to equalize the cost, how many should each sell? Should it be 1,500, 500, or what? Obviously, you could guess and check. You could just start throwing numbers into it, but using the algebra, we can probably come up with a sensible solution faster. Well, it depends, and technically you could use the guess and check method, but we're going to obviously focus on the algebra. So what always helps is to start by writing what I know, writing the equations. But also, general rule of thumb, as we discussed back in chapter 1, is when I'm trying to solve a problem, I want to figure out what are my variables. And in these problems, we're typically going to have both x and y, and we're going to use those variables to do it. But we can always focus on what we don't know. I mean, it's good to focus on what we do know, because that's what I have. But focusing on what am I trying to solve, excuse me, that's going to be the x and the y in our system. Notice in the question, it should usually tell you what you're looking for. It's going to tell you what you're looking for, and should typically be what x and y will be. But what it says is how many pieces of furniture must be made at each site. So basically, it's like, well, how many are going to be made in San Diego? How many are going to be made in LA? Those are going to be x and y. So let me just go ahead and note that before I do anything, which is a good habit to be in, but you don't have to. But you could call them S and L for San Diego and LA, because again, you can use whatever variables you want when solving systems, but I usually recommend just using x and y since we're so used to doing that in math class. But let's say x is the number of pieces made in SD, and y is the number manufactured in LA. And that should be enough for me to remember which is which when I'm solving it later. But there also, this is going to be a systems question because I'm given some different pieces of information. Number one is the cost to produce those furniture in San Diego. So what I could do is I could write the cost of SD, or I'll just write that as the cost of X. Is going to be, well, it's $8,000 fixed per month, and then it's going to also cost them $12 per furniture. And remember, that's, $12 times the number I make in San Diego should give me how much it costs to produce. Say 100. Let's say I make 100 in San Diego. That's going to be $1,200 plus the 8,000 fixed, which is independent of how many pieces I make. And then the cost to produce the number of pieces in LA is going to be based on Y. Their upfront cost was $3,400, and their variable cost was $14 per piece of furniture manufactured. And basically, so the key here is that our goal is to equalize the cost, meaning that we want these costs to be the same in both facilities, aka equal. So what that actually gives me is a system of equations, not a system, sorry, a new equation that 8,000 plus 12x must be equal to 3,400 plus 14y if I'm properly solving the equation. Now, what I don't know is what is the actual cost that makes sense, but that's actually not even relevant to solve the question. Now that is one equation. The other equation was a little bit more obvious and a little bit easier, but that's coming from the second part of the information, and that's kind of how I think about it. Usually each sentence gives me something, and usually each sentence gives you a different part of the equation, or a different part of the system, I mean. But if I'm looking at the second sentence, it says next month, Megacorp must manufacture 2,000 pieces of furniture. And that's basically the total amount. But basically, if that should be the sum of both x and y. Because however, I have two facilities. If I make say 500 in San Diego, all the rest are going to be in LA. And since I know those two add up to 2,000, x plus y is the sum of my both factories' production of furniture, which must be 2,000. But what I can see is I have a system of equations here which is not necessarily ready to solve, but I could then use either elimination, substitution, graph, however method I want to solve it, since I have two equations with two unknowns. And let's go ahead and use substitution just because that's what I think will be easiest here. I could solve for x by subtracting y to the other side. So x should be 2,000 minus y. And this makes sense because if I take the total amount of furniture and subtract the amount made at one facility, that should give me the amount made at the other facility. And if I then substitute this into the first equation, basically it's kind of the same idea. Well, I know x must be related to y in this way, and so I could substitute it in, and that would leave me with a single equation with only one unknown, which is always solvable. So that would give me 8,000 plus 12 times 2,000 minus y should be equal to 3,400 plus 14y. And I could then simplify this equation and solve for y. So by distributive property, I would have 8,000 plus 24,000 minus 12y equal 3,400 plus 14y. And now I want to put all the y's on one side, put all the numbers on the other. So I could add 12y over here, and I could subtract 3,400 over here. And that should leave me with a much simpler equation. 26y is equal to, well, 2,400 minus 30. Let's just do the larger numbers first. So this would be 3,200, whatever. I'm just going to use my calculator because I don't want to mess it up. 3,200. What am I doing? 32,000, I mean. 32,000 minus 3,400. And that would leave us with 28,600. And then I could divide through by 26 to get y. And apparently here y is equal to 1,100. And once I solve y, it's helpful because once you get focused on the math side, it's easy to forget about what is the actual problem at hand. But thankfully right here I have written down, well, what is y? Y was the number of pieces of furniture that I manufactured in the LA facility. So obviously that leaves me with 900 for the San Diego facility because the total was 2,000. Or of course I could plug it back into the simpler of equations, plug back in y, reverse the substitution, and find my ordered pair. And we could write our solution as an ordered pair, but it's usually recommended to write out your answer using a word sentence. So I know I need to manufacture 900 pieces of furniture in San Diego, 1,100 in LA, and that would equalize the cost of production at both facilities. Actually, notice I didn't even calculate the costs, but I could then use these individual functions to make sure that the cost is the same and solve that. Which let's go ahead and do, even though it did not ask us to do that, because if it were doing business, this is something we'd want to know. But basically, my cost in San Diego would be $18,800 per month for this month, and that should be equalized by LA, assuming I did that correctly. And we made 1,100 in LA, which is equal. Cool.